Hi there everyone, how are you? I hope you're having a good day, and in this video we're going to talk about the basic properties of matter. So I'm going to assume you know what elements are, but how do they work? How do they all go together to make the world that we see and that we live in? In this part of the video, we're going to look at metals, non-metals, and physical reactions, along with physical qualities of matter. A quick review of what I think you have done already. We're going to talk about what elements are and what they are made of. An element is a basic building block of matter. Everything is made of elements, and they cannot be made of any simpler substances. An atom is the smallest possible unit of a chemical element. We can break atoms up, but then we do not have an element anymore. We have something else. A compound is a chemical substance that is made of several elements. For example, H2O, water, has 2 hydrogen and 1 oxygen for each part of the compound water. And that part is called a molecule, which is the smallest possible unit of a chemical compound. You cannot make water with anything smaller than 2 hydrogen and 1 oxygen. A molecule is also a natural unit of an element sometimes. For example, oxygen in the atmosphere travels around as O2, which is a molecule made of 2 atoms of oxygen. Finally, we might mention a mixture, which is a combination of different chemicals together. No chemical reaction happens, the atoms and compounds are just in the same container or in the same solid lump. You may also have learned about the periodic table. This is the way that we arrange the 118 elements that we currently know about as of recording this video in 2020. The table was designed by the Russian Dmitry Mendeleev at the beginning of the 20th century, and that is quite a story in itself. But the table is divided into vertical groups, which have elements that have similar chemical properties together in them, and horizontal periods. Elements with larger atoms are in lower periods, but as we cycle through the groups, we get a periodic repeating of certain chemical properties. And here is the table that you have probably seen in school. All of the elements are here. And in this table, we don't actually have the chemical names, we have the atoms, and you can see those atoms getting bigger as we go down the table. If we have a look at some of the elements, we have helium, one of the smallest atoms in the table. Near to that is carbon, one of the most important atoms for life. Way over on the left, we have sodium, which is a metal, slightly bigger atom this time. And in the middle of the table is the metal copper, which has a slightly bigger atom again. One of the largest atoms in the table is uranium down at the bottom there, and this is another element that we make use of in our modern world. If we put up examples of all of these elements, you can see that some look the same, some look different, and all the elements have different physical qualities. Before you go on to the next slide, just stop and have a think about what those qualities are. One of the ways that we divide up the periodic table is into metals and non-metals. What are the differences between metals and non-metals? Have you thought about it? Well, the difference is metals are usually solid at room temperature. They are usually shiny, malleable, ductile, and stable, which means once you have a block of metal, it will stay a block of metal. Metals are also good conductors of heat or electricity, usually. Non-metals, on the other hand, are not always solid at room temperature. They come in various forms, and they are usually bad conductors of heat or electricity. And you'll notice that I was using the word usually a lot there because, like many divisions that we make in science, they are not exact. Metals and non-metals do cross over some qualities. For example, the metal mercury is a liquid at room temperature, the only one that is. Sodium is a metal, it can be cut with a knife and it burns away in water, so it is not very hard or stable. Magnesium is a metal that is also quite soft and can be burned in air. And graphite, a non-metal form of carbon, can conduct electricity very well. Physical reactions are just that, physical, when no chemical change takes place, but matter changes in the outside world. Simple physical reactions include phase changes, like melting, a substance changing from solid to liquid. We see this with ice at room temperatures, but you can also melt a block of metal into a liquid if you have a hot enough furnace. Freezing or solidifying is the reverse of this process. A substance changes from liquid to a solid form. Evaporation is when a substance changes from liquid to gas, and we can see this with water when it reaches 100 degrees centigrade or even before that. Condensation is the reverse, which you can also see on your cold drink on a hot day. A substance changes from gas to liquid. Water vapor in the air condenses on the outside of your glass to form liquid water. And then there is a phase change we do not see so often in everyday life, sublimation, when a substance changes directly from a solid to a gas. You might see a little bit of this when your ice steams slightly on a hot day, or dry ice in a smoke machine is another example. All of these phase changes are physical reactions, but another very popular physical reaction is the Mentos and Coke reaction. This looks a lot like a chemical reaction because it is so impressive, but really the Mentos are just providing a surface and CO2 gas can escape very, very quickly from the soda, and then the narrow neck of the bottle does the rest. This is a Mento. It looks smooth, but if you look closely, you can see it's not quite the same shade of white all over. There is some texture to the color of the surface. This is a glass of soda water. You can even see some condensation forming on the outside of the glass. Wait a minute. Okay, now you can better see the bubbles of carbon dioxide rising up, because once you open that bottle, then the CO2 will not stay dissolved in water at normal room temperature and pressure. If we now add a Mento to this glass, you can immediately see the bubbles forming around the surface of the Mento, because the surface gives a lot more places for the bubbles to form, and so the CO2 can escape more quickly. These places are called nucleation sites for the bubbles. But because the glass has an open top, we are not bubbling over because all of the gas can escape before the bottle fills with foam. You can see there are far fewer bubbles rising already, and if I taste the water, it's still cold, but it's not very bubbly anymore, and sadly not even a little bit minty. So, physical matter has different qualities that allows it to do different things, both physical reactions and also chemical reactions. There are many different qualities that tell matter apart. You have already thought about some of these with the periodic table and metals above. But it is the structure of atoms and molecules that make these different qualities real in the real world. And we are going to look at some of the more formal qualities of matter. These are hardness, density, malleability, ductility, and tensile strength. Hardness is a measure of how hard something is, obviously. But it is a simple test. You just scratch substances against each other, and a harder substance can make a mark in a softer substance. The Mohs 10-point scale of hardness is not a very precise scale, but it is useful for dividing roughly into hardness groups, and scientists have more precise tests for measuring hardness at a smaller level. Density, on the other hand, is about how much stuff there is in an object. A sponge and a stone can have exactly the same size and shape, but the stone will be much heavier because it has more density. So density is a measure of how much stuff there is in an object, how much actual matter, and this is closely related to the mass of an object in kilograms. But density does not mean strength. Something can be very dense but also much weaker than another substance. Carbon fiber is much lighter and less dense than steel or aluminium, but it is much stronger than both of these metals. Next, we're going to talk about ductility and malleability together, and to get us started, here's a quick question. Pause the video and answer, what is a force? What do you think a force is? Well, I'll tell you that from science's perspective, a force is a push or a pull. A force can change the movement of an object, which you will learn about in mechanics. It can also change the shape of an object, and that is what interests us here. When a push squeezes on an object, this is called compression, and compression can change the shape of an object. When a pull stretches an object, this is called tension, and this can also change the shape of an object, but in a different way, and this is the difference between ductility and malleability. If a substance's shape can be squeezed without breaking the substance, then it is malleable. If a substance's shape can be stretched without breaking the substance, it is ductile. Now, this might not make a lot of sense yet, so let's just look at a few examples. So here are just some quick everyday examples of malleability and ductility. This is a rock, and if I squeeze it, you can see it is not malleable, and if I try and stretch it there, you can see it is not at all ductile. You might think that metals are like rocks, because we can't squeeze them with our fingers, but many metals, if you have enough force, are very malleable and very ductile. Next we have some modeling clay, and now we can see I can squish this fairly easily. This is quite malleable, but if I try and stretch it, it very quickly breaks, and you can see the rough edges there where it has broken. So it is not really very ductile. It cannot be stretched without being broken. Now let's look at this white tack here. Again, this is quite malleable, maybe not quite as malleable as the clay. It's a little bit harder to push, but if I grab it and stretch it, you can see that it stretches out way past the edges of the camera shot, and this is quite a ductile material. And next we have a sponge, and here we have something which is quite malleable. It can be squashed without breaking, but it is not very ductile at all. It stretches a little bit and it does not break, but then it will not stretch anymore. So it is not ductile. Something the sponge does have though is elasticity, and that means when you change its shape by squishing it or pulling it, it will always go back to its original shape afterwards. It is elastic. And one last example here, this is some mud. It's just everyday mud from out in the garden, and if I get my fingers in and grab a bit up, I can grab it as a lump, and you can see it's pretty malleable. I can change its shape very easily by squishing it. But if I take it and I try and pull it apart, it comes apart immediately. It isn't even a little bit ductile. As soon as you put it in tension, it breaks. Let's also talk about tensile strength. Can you recognize anything about this name? Well, the first word tensile seems connected to tension, which we saw on the previous slide. If something is put in tension, eventually it will deform or break. Tensile strength is a measure of how easy it is to break something or to deform it when you put it under tension. This is not the same as ductility. Something can have a very high tensile strength, but then have a very low ductility. For example, toffee is very ductile, but it has a low tensile strength. It is very easy to change its shape. Stone is not ductile at all, but it has a much higher tensile strength than toffee. While we are introducing these physical qualities, I want to go out of my way to mention they are not the same. This sounds really silly, but we give things different names because they are different things. It can be hard to work out how they are different though. How is tensile strength different from hardness? How is hardness different from density? We have talked about these things, but it's not always easy to get a feel for exactly how these things are different. Try to use some examples like the ones I have given or other ones to make these qualities very different when you think about them. This is one of the important skills you need to master when studying science. Let's also remember that we haven't looked at all possible physical qualities. Some that we haven't mentioned include luster, the quality of being shiny. Sonorance is the quality of carrying sound waves. Conductivity is the quality of carrying heat and electricity, another thing metals are known for being good at. But there is also volatility, which is the quality of vaporizing, and this is something you do not see in many metals. They do not change phase until very high temperatures, except for mercury. And that is our look at the physical qualities of matter, some basic physical properties. Obviously, each one of these different qualities can be studied in depth, but that is a topic for an individual video on each quality. I hope you've enjoyed this video. If you have, please leave a like, maybe share it with a friend, and ask any questions or give any comments you have down below. You can also subscribe to my EP for more science videos, and thanks for watching, and bye for now.